Our next presenter is from Ecolab Purolite Resins. Joining us is Karen Green, Senior Marketing Manager for Bioprocessing. Ecolab is committed to offering flexible, modular approaches to purification that align with specific molecular types, manufacturing scales, and business goals. See how advanced purification methods can provide the highest dynamic binding capacity and less aggregation and caustic durability for your monoclonal antibody capture. Welcome, Karen.
Hi there. Thank you for attending this presentation. My name is Karen Green, and I am your Ecolab Senior Marketing Manager. So our bioprocesses are facing increasing challenges when striving to optimize and achieve antibody purification manufacturing efficiencies. And Ecolab is committed to offering flexible, modular approaches to purification that align with the specific molecule types, manufacturing scales, and their business goals. So in this presentation, I'm going to walk you through options for choosing between different advanced purification methods that can provide the highest dynamic binding capacity, targeted less aggregation, and the highest caustic durability during your monoclonal antibody capture process, and overall help reduce operating costs to manufacture. But first, I want to introduce you to Ecolab. So for 100 years, Ecolab has worked to improve the health of people, the planet, and businesses around the world. At Ecolab, we aim to bring science-based solutions, data-driven insights, and world-class services to advance food safety, help maintain clean, safe environments, and optimize water and energy use. Today, we're going to discuss solutions we're bringing to healthcare and to pharma industries, particularly those to the development of therapeutic medicines using our Purolite resins. So as we look at this side, over the last 20 years, as we see on the left-hand side of the graph, we've seen a huge innovation in the biotherapeutic market. So in 2023, there were approximately 400 monoclonal-based antibodies molecules from preclinical to launch. 90% of those were monoclonals. However, if we slide over to the right-hand side of the graph, in 2023, there are now over 3,200 monoclonals. But however, that 90% has been reduced down to 59% because there's a strong growth in bispecifics, multispecifics, ADC, FC fusion, all types of molecules that become a little bit more complex. So while this door is opening to new treatments of diseases and increase in patient care, the new molecules are often trickier to manufacture. Innovation from vendors like Ecolab and others that are presenting today, it's required to ease the burden of the downstream process complexities. You're now seeing an increase in more complex MABs in your processes. So what challenges does that give the bioprocessor? You're not alone in this challenge. We've been hearing this from many new antibody formats that are prone to aggregation, particularly at low pH, which is a problem when using protein A, and the affinity capture steps, which, as you know, necessitates the need for low or mild pH elutions. And let's not forget the lion's share of the traditional monoclonals requiring optimization of first-generation processes. They're still in existence. They're still solving the medical issues of today. We want to bring in process to help intensify yields, reduce COGS, minimize resource uses, and speed the bioprocess's next generation molecule to market. To set the stage, we know that most purifications at manufacturing follow a three-step process: capture, intermediate purification, and polishing. Capture focuses on isolating your protein from the feed as fast as possible. This protects your target from harm that can be caused by components in the feed, such as the majority of HPCs and proteases. At this stage, your sample volume, large, so you can concentrate it, is also the aim too. The second step is where the intermediate purification happens. This is removing more of the HCPs, or host cell proteins, bioburdens, and DNAs. And then lastly, there's usually a final polishing step to remove any leftover traces of impurities, normally things that were very close in physical property, for example, modified target molecules, aggregation, incorrect glycolization, etc. But today, affinity chromatography is specific that it can perform capture at most times. Intermediate purification is one of the steps. For the rest of this presentation, I will be focusing on affinity chromatography only. That's the yellow box to the left. Ecolab has a broad range of Purolite resins to address purification challenges. Whether you are looking to increase productivity, drive down costs of goods, retrofit into an existing purification infrastructure, or you have a complex molecule that requires an advanced innovative capture method, there's a unique Purolite resin that will be the optimal fit for your molecule. To the left, we have a set of 3 resins that address optimized productivity and cost reduction abilities. First in line, our flagship DuraCycle A50 resin demonstrates a high dynamic binding capacity, and its name suggests durability and caustic stability in both 0.1 molar and 0.5 molar NaOH. The more runs one can get through a packed resin campaign, the more favorable the cost to manufacture is. DuraCycle A50 would be a resin that you would choose in those situations. Second, we have our latest innovative line that we just launched this past June, Presto AP Plus resins. The resins have been designed to be true workhorses for the traditional MAB purification. Currently available in a 50 micron and an 80 micron bead size, the size flexibility when column packing helps address pressure flow abilities, which in turn contributes to economic efficiencies realized in time to process, amount of material used, while still maintaining a high dynamic binding capacity. Aggregation is also seen to be minimized. Last of the 3 to the left is our time-tested Presto Jetted A50 resin. The Presto Jetted A50 resin that performs daily in commercial scale bioprocesses across the globe. Jetted A50 manufactured with its patented jetted technology produces uniform 50 micron size beads. The size consistency works ideally in reproducing intensified process cycles repeatedly. Now to the right side of my slide, I want to talk about resins that we have in our portfolio that uniquely address more complex molecules. I'm going to introduce the 2 specialized resins that were designed to address the growing range of more complex molecules being developed at the latest therapies. First, our bioprocesses are developing bispecifics and trispecifics, FC fusion molecule types, other molecules as shown earlier in slide 3. With that, our Presto Jetted A50 high pH affinity resin can still provide viral clearance and acceptable removal of impurities at pH ranges that are not so aggressive and still protect the integrity of the molecule while achieving the purity desired, and also resulting in less aggregation as seen. Also, our bioprocesses work with molecules that, when targeting a specific antibody domain with a purification method, it can simplify the complexity of the process and still deliver a high capacity recovery. So here, in our last resin to the far right on this slide, Ecolab's Presto 70 CH1. This resin can target the CH1 domain of the monoclonal antibody, enhancing the purification that may otherwise not have been as effective with a traditional affinity resin targeting a different domain. With improvements to upstream, the demand for robust, flexible, and economically viable resin technologies has never been greater. Purolite resins rose to the challenge of producing an innovative resin range that is designed to address these clear market needs and improve one's processing. So to summarize, the Ecolab Purolite has affinity resin choices that focus on, first, caustic stable resins that extend the resin lifetime, that contributes to lower COGS, resin bead size differentials to help enhance pressure flow property requirements. Again, in our AP Plus line, we have a 50 micron bead and an 80 micron bead. As you're packing 50 micron, the height of a bed may get too compressed, and therefore a larger resin bead will alleviate that and allow you to have the process flow that you desire. High capacity resin designs for process intensification, continuous processing, and multi-column chromatography processing can be achieved with that patented TED technology jetted resin. The resin bead sizes are more uniform and therefore can contribute to repeatability lot over lot. The high pH resins for targeting less aggregated bispecifics or FC fusion molecule purifications are unique to be able to address those complex molecules. So choosing the high pH does allow you to elute at a milder elution and therefore producing a more purified product. Resins that target specific antibody domains to help simplify complex purifications. Also, as molecules evolve and therapies are treated with different, more complex designs, different resin capabilities need to be innovated and reintroduced into the market to be able to address being able to purify at the levels that are traditionally understood with these new therapies. So for more information on Ecolab's Purolite Affinity resins or any of our chromatography products, please visit ecolab.com and explore our bioprocess knowledge hub. Within here, we not only have affinity resins, but also ion exchange and other process capabilities within your laboratory processes. So thank you for attending our presentation today, and I'm open to take questions.
Thank you, Karen. Great presentation. Are there resin options that can help counter pressure flow increases in my columns?
Yes, there are. So when a bioprocessor is packing a column, usually kind of the cutoff point is about a 20 centimeter bed height. Below a 20 centimeter bed height, you can use a smaller resin bead. That particular resin bead usually produce a high binding capacity efficiency. But however, when you start to pack above that, the packing almost minimizes that capability of binding, and therefore the efficiency will go down of that binding capacity. So if you are to bring in, say, a larger side bead with the same ligand, the larger side bead will create crevices so that the flow path will open up and will run, the pressure flow will be alleviated, and therefore you can then resume into the actual binding capacities that you would expect, say, from a smaller bead, still in that larger bead cycle, while still packing your column height even higher than traditionally you would only have the capability of as a smaller bead.
Yeah, great explanation. Can choosing the right resin also help me reduce costs?
It can. So I'll use our DuraCycle 50 as an example of a resin that to help reduce costs. So DuraCycle is designed to be able to be caustic stable. Therefore, the number of runs that you can get out in a campaign, whether with traditionally a generation 1 resin, maybe you would get 100 cycles. If you are able to then replace that with a DuraCycle, which is known for its durability, to run 200 cycles, you'll cut your manufacturing costs in half. Also, you may be able to use less resin and also, again, the longer runs, and while maintaining that same high dynamic binding capacity that is expected from a traditional affinity resin.
And are there benefits to using milder pH resins?
There are. We do see as these more, we refer to them as complex molecules, but however, the aggressive pH range purification elutions that we would traditionally do can be negatively affect the binding capacity, or be detrimental to the actual molecule itself. So the requirement for these more, say, complex or fragile molecules, you want to be able to produce a milder pH. And with that, we've designed resins that are capable of operating and delivering the capacity abilities that are required at a lower pH or a milder pH level. So there are opportunities to design unique resins to address these complex or fragile molecules as they come onto the market.
Excellent. Karen, thank you very much for being with us today. Karen Green from Ecolab Purolite Resins.
Thank you.